Okay. Today we're going to take video notes on Chapter 14, Topic 1, which should be super easy. It's just on the fundamental counting principle. Um, it starts out with two events, and it says if one event can occur in m ways and another event can occur in n ways, then what is the number of ways that both events can occur? Well, what we do is we multiply those possibilities together, m by n. So let's say that a basketball team has various shirts and shorts they can wear for their weekly game. Their shirt colors include red, white, and silver, while their shorts are available in blue, black, heather gray, and forest green. How many different uniforms can the team select from to wear for this week's game? Well, there are basically two different things. There are shirts and there are shorts. How many different shirt choices are there? 3, red, white, and silver. How many different short choices are there? 4, blue, black, heather gray, and forest green. We multiply those together and we get 12. That's literally it. And you can extend this to 3 or more events. So if 3 events can occur in m, n, and p ways, then the number of ways that all 3 can occur is m times n times p. So let's say we have a sporting goods store who specializes in custom designing for bikes, and they have a variety of choices, and they can select from 3 different kinds of bikes: BMX, racing, or mountain. They have the option for 3 different wheel sizes: 20, oh gosh, you can't even see what I'm pointing at, 20, 22, and 24, sorry. 2 wheel colors, white and black, 2 seat sizes, and 5 bike colors. How many bike choices does the store offer? Well, they have 3 different kinds of bikes. They have 3 different wheel sizes. They have 2 wheel colors. They have 2 seat sizes, and they have 5 bike colors. So what we would do is we would just multiply all those different pieces together to find that there are 180 choices. That's it. So you just multiply all the choices together. And sometimes that will bring us to something called the factorial. The factorial of a positive integer is the product of the integer n and all the positive integers below it. So 6 factorial, for example, and that's how that's read, not 6 exclamation point, but 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. And that's it. By definition, 0 factorial gives us 1. And on the calculator, there are a couple different places you can find the factorial. On a scientific calculator, sometimes there's a factorial button itself. On this scientific calculator, you would have to press shift to get it. So if we wanted to find 6 factorial, for example, we would hit 6, then shift, and then that button. And then we can see in the calculator it says 6 factorial, and it tells us our answer is 720. On the graphing calculator, what you could do is you can hit the math button, arrow to PRB, and then number 4 is the factorial. So if you wanted 6 factorial, you'd have to hit 6, math, PRB 4, and then that gives us that 720 also. So if you want to write that on the graphing calculator, since we're supposed to have those, you can go to math, you can arrow over to PRB, and then number 4 is your factorial. Okay? So this says a basketball coach has a total of 9 players and needs to come up with a batting order for their upcoming game. How many batting orders are possible for the coach to create? Well, when you think about it, there are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 different batters batting. And if he has 9 players to choose from, then he has 9 players to choose from at first. But then after that player has batted, he only has 8. And then after that, he only has 7. And this continues down the line until at the end, he only has 1 to choose from. Using the fundamental counting principle, we would want to multiply all those possibilities together. And we might notice that this fits the definition for factorial, but this is the same as 9 factorial. So either way, we could type all of this in our calculator or just 9 factorial. And when we do that, we should get 362,880. Well, let's see what happens here if there are some restrictions. There's still 1, 2, 3, 4, 5, 6, 7, 8, 9 people batting. But the coach decided that the pitcher must bat last, so this has to be our pitcher. And our catcher must bat first. So now how many batting orders can the coach create? Well, if the catcher has to catch first, there's only 1 of him. So there's 1 possibility for that guy. There's only 1 pitcher, so there's 1 possibility for this guy. So now that we've had 2 players that we've already assigned positions to, how many players are left to choose from for this position? Well, there are only 7. And now that you use that guy, there are only 6, etc. And now we can again multiply all the way down. We know that using the fundamental counting principle, we would want to multiply all these together. And what we might notice is that in this piece right here, that's equivalent to 7 factorial. And when you multiply by 1, it doesn't change the order. So we could either enter all of this in our calculator or just enter 7 factorial, and we would get 5,040. Okay? So if we evaluate in our calculator 10 factorial, again, what we could do is we could hit 10, math, PRB 4, and we get 3,628,800. So again, we get 3,628,800. But let's say that we tried to put this in our calculator. Let's say we tried to put 120 factorial over 118 factorial. Notice that this gives us an overflow. So that means that it was too big for the calculator to handle. So let's think about what this really means. What this means is 120 factorial means 120 times 119 times 118, like all the way down, right? We won't write all of them. And 118 factorial means 118 times 117. Do you notice that we have these pieces here that are the same in the numerator and denominator? So in a case like this where we have overflow, we're going to have to cancel out those common factors and just enter in our calculator 120 times 119. That the calculator can handle. We get 14,280. So be real careful in those overflow problems. Okay? I'm going to put, just for time's sake, the answers to the U-tries. Again, on the back, these are on ePark for you to look at, the answers. Remember, the password for you guys is SRS. But I think sometimes examples are a good way of helping. So I can put, again, these answers here for you real quick. So that you can maybe try these and double check. Okay. Also a reminder that in the homework tonight, like the odd answers are in the back of the book and are a good way for you guys to double check what you're doing. And that's it, okay? And hopefully you can finish the assignment before you go. All right, see you guys soon. Thanks.